Hi, welcome you all on Physics Addhyan YouTube channel. As I have announced that I will be covering 100 plus important question for JAM 2020 for physics entrance. So, this is the very first video, and I will be starting with quantum mechanics. So, not a very detailed theory will be discussed, but I will solve the problem and I will let you know that what other topics you should study from those particular topic or what other types of questions can be asked. So let's start by having a very first question in quantum mechanics from photoelectric effect. And this is an objective type question. So I will also give you some options where there is needed, or I will for multiple select answers, I will also give you answers for NAT type questions. I will not give you the answers and you have to fill in that blanks. So all the type of questions we will practice here. So let's start with very first question on quantum mechanics. So this is a question. In a photoelectric effect experiment, a screen of photons of frequency f is incident, frequency f and intensity I is incident on the photocathode to produce a photocurrent I. If the frequency f is continuously reduced without any change of intensity, the plot of current versus frequency will look like. So most of you, I'm not saying to all, but most of you, while having a graphical question, you mostly get confused. So that's why I started with a graphical question. So let's look at the details of this question. So it's a photoelectric experiment. First thing, frequency is given to be f and the intensity is I. So frequency is f and intensity is I, and the current is represented by I, small I and capital I. So this is intensity and this is current. If the frequency f is continuously reduced without any change of intensity. So see, we are reducing the frequency, but I am keeping fixed this term. This is the intensity is fixed. So how will you current versus frequency look like? So see, this is a very simple question. So this question only needs the definition of intensity and the concept of photoelectric effect, result of photoelectric effect, which shows that the energy is quantized. And the second, okay, let's start with the intensity, and then I will, if there is a problem arise, then I will discuss what that is. So intensity is energy per unit area per unit time. Okay, so that is the energy. Now what they are saying, that intensity is fixed. And the second thing, you need to know that the energy is quantized in photoelectric effect experiment, which shows that energy, the incident energy photon of frequency f is hf. Most of the time I write is at h nu, since I have used a symbol f, so I will write it at hf, or you can write it as h nu. Okay, let me write it as h nu. So energy is h nu per photon. This is the energy of photon. So this is energy of one photon. Okay. Now let's suppose there are np number of photons. Np means p means photon and n means numbers. So there are np number of photons. So the total energy of the photons will be np h nu. So now just put it the symbol I is equal to np h nu per unit area per unit time. Okay. Now from the question it is shown that this intensity is fixed. This is a fixed quantity, and we are also assuming that the area and time, everything is fixed, and the frequency is reduced. So this is reduced. If you reduce the frequency, then what will happen to keep the intensity fixed? Np will increase. Okay, if Np the number of photons will increase, then the primary electrons that are emitted by when the light of this particular energy h nu fall on that material, then the electron will emit. That if Np will increase, then the number of primary electrons will increase. If number of primary electrons will increase, then the current due to those electrons will increase. So what's the conclusion is, if we reduce the, if F is reduced, then current should increase. Okay. Now look at the options. This, if F is reduced, the first option, if F is reduced, the current is constant. This is not the right answer. This, if F is reduced, the current goes down. So this is also not a right answer. This, when F is reduced, the current is almost constant, then it goes to zero. And from this option, when you F reduced, it the current is increasing till a value, then it will suddenly decrease to zero. So there is an another explanation why this should happen, because for photoelectric effect experiment, you all know that there should be there is a threshold on the frequency. Above that frequency, that photoelectric effect is dominating. Below that frequency, there is no photoelectric effect, and that the energy required is which we call as a work function. Okay, so if the energy is below the work function, then there is no emission of electrons. It means there is no current. So this part, so you can call this frequency as mu naught. That is the your work function frequency. If the frequency is greater than this mu naught, then only the primary electrons will emit and the current will flow. Otherwise, there is no current. So two options shows that there is a threshold on frequency, and this was a photoelectric effect experiment. So the option should be 3 or 2. Since we have worked out this, so option is second, because if you reduce the frequency, then the current will increase till a threshold, and there will be, it will be zero. So the correct option is second one. Now there can be a different question from the same question, that what will be the graph of this primary electron, the current, basically what will be the graph of current versus frequency if we keep the intensity fixed. So this is look like something look like that. I think you all know this, but this is also an important question. So suppose this is a current due to these primary electrons, this is increasing in this direction, and this is the frequency of the incident photon. So not exactly frequency, this is sorry, here is a slight correction. This is not frequency. We should plot it to applied voltage at different frequencies. Okay. So here is the applied voltage which you apply across the terminals, cathode and anode. So at a fixed frequency, let's say mu1, the graph will something look like this. It will increase till a will some current value, then it will saturate to a maximum IPE current, that is IPE, let's call this as a maximum. This is at frequency mu1. Now this voltage at which the current due to electrons is zero, that is called the stopping voltage. Let's call it as Vs, stopping voltage, due to the first frequency. Now let's suppose there is an another frequency mu2 which is greater than mu1, then how this graph will change? So for a higher value of this mu2, there is a higher value of stopping voltage. So this graph should start from a more lower value of Vs2, then it will start rising, and then it will again saturate to IP maximum. So these are two type of questions. The first question asking about the intensity, this current versus intensity, and the second question was asking about current versus the applied voltage at a applied voltage at different frequencies. So these were the basic questions that were asked in different examinations. Like the first question, this was asked in JNU, and this question was asked in JAM examination, and many more. And you should, the most important topic from this photoelectric effect is that the equation, that energy which is h nu of a incident light is h mu naught, that is a work function you can write it as phi naught minus, sorry, plus kinetic energy of electrons, plus kinetic energy of electrons. So from here you can reduce that kinetic energy of electrons is equal to h mu minus h mu naught. So most of the times the question that has been asked from photoelectric effect are very simple. You just need to analyze what the conditions are, like which term is constant, which term is varying. So you have to look at the problem, see which term is varying and which is an important topic, and then proceed. So the first topic that is most important for jam preparation is your photoelectric effect. Photoelectric effect. Do this topic very rigorously because you will be taking JEST examination, and I don't know, JNU has uh, I think JNU also have this in syllabus. TFR exam already has been done. So for just upcoming examination and JAM examination, you should study this photoelectric effect very rigorously. Okay, now let's move to the second question. Okay, now our second question is, let me read it. An X-ray of 20 kilo electron volt energy is scattered inelastically from a carbon target. The kinetic energy transferred to the recoiling electrons by photons scattered at 90 degree with respect to the incident beam is uh, how many kilo electron volts? So this is a question of inelastic scattering of an X-ray with a which target. This is a carbon target. So this is a question from uh, what the topic is named by Compton effect. Okay, the topic is Compton effect. Compton effect. So let me solve this question, and I will also tell you the different important formulas from this Compton effect, because this is one of the most asked topic from quantum mechanics, and this question I have taken from JAM exam itself. So this was asked in JAM. I don't know, I don't remember it was 16 paper or 15 paper, but this was in the JAM exam. So the question is a strictly formula based question. So you have given this angle is 90 degree, and the incident energy energy is given to be 20 electron volt. The energy of photon which is incident is given to be your 20 kilo electron volt. Now you have to find the energy of recoil electron. So it's there is a direct formula for for this topic, and when I will be dealing with put Compton effect in our regular lectures, then I will derive this formula. So this is equal to h mu naught square divided by m naught c square divided by 1 plus h mu naught by m naught c square. Okay, this is the formula. So here you just directly substitute this value. So h mu naught is, this is h mu naught, the incident photon energy. So this is given to be 20 into 20 kilo electron volt multiplies by kilo electron volt. I always write this so that I do not miss any power. Divide by m naught c square. M naught c square, what will be the value of m naught c square? M naught c square is 511 kilo electron volt. This is the rest mass of electron. So divide by 511 kilo electron volt, 1 plus 20 by 511 kilo electron volt divided by kilo electron volt. The most common mistake in JAM exam is that we miss these factors. Here they are all kilo electron volts, so here will be no problem if you don't write this. But in many questions they give kilo electron volt, mega electron volt. They all three combinations will be in a single question, and if you miss a single one, there is a huge difference in between the powers. So make sure you just write it down to don't. So this kilo electron volt, this will cancel out. So this is 400 by 511 by 1 plus, sorry, 20 by 511. There is a calculator given in your JAM examination. If you calculate it, it will be 0.7532 kilo electron volt. So most of the time you have to write a two digit number. If not specifically given, right, like 3 digit number or 5 digit number, 3 digit number, 1 digit number, or a integer. So read the instructions very carefully in the examination. So here you can fill this blank at 0.75, and don't worry about the examination, like the range of this answer will be given from 0.7 to 0.9. So look, it's a rough idea. If your answer is in between this, this and the solution will be correct. But this range is also defined by how much accuracy you have given to your question. Suppose if you miss a power, this will be okay. So this was a question from a content effect. Now let me tell you the different formulas how you can get directly, because you can always calculate this by your regular method, writing momentum conservation, energy conservation, but uh, the number of questions and the time you have given, it's very important that you should remember these formulas. So the general idea of Compton effect is like Compton effect, uh, this change in wavelength delta lambda, which is lambda prime minus lambda naught. Lambda naught is your original and lambda prime is your scattered, is equal to h by m naught c. M naught is the rest mass of electron, 1 minus cos phi, where phi is your scattering angle. Scattering angle. Now you have to also remember this value of h by m naught c. H by m naught c, which is also known as Compton wavelength. The value of Compton wavelength is 0.02426 angstrom. You should remember these values because most of the time these questions is all asked only to check your memory, that whether you have remembered these values or not. So this is about the wavelength. If you want to, this is the first. If you want second, energy of a scattered photon. The question was asked for scattered electron. Here you can directly calculate the energy of scattered photon, which is nothing but this energy. Let me write it as E prime is equal to your original energy plus 1 by 2E by m naught c square into, or you can directly remember this formula. Don't remember this 2 and all that. You just throw out this 2 and 1 minus. Just put 1 minus cos phi. If you can calculate this, 1 minus cos phi is nothing but 1 minus 2 sine, uh, this is 1 minus 2 sine square phi by 2. So this 1 cancels. So this is 2 sine square phi by 2. So you can directly substitute this 1 minus cos phi to 2 sine square phi by 2. Okay, so these were the two formulas, and this is the third one, the kinetic energy of the scattered electrons. So if you remember these, I hope you will be able to solve any problem on Compton effect and remember these values also. Okay, now let's move to a next question. Okay, now this is the third question. The question is the energy density for a black body radiation is given by there is a slight correction, given by u mu, that is energy with a function of frequency. Then u 2 mu by u mu varies as in order to solve this question, you need what the value of, what is the expression for energy density. So the black body radiation, so energy spectral density u, I remember mostly in the terms of lambda. So it is 8 pi hc by lambda ki power 5, 1 by e raised to power hc by lambda kbt minus 1. So this is the general expression for energy density of a black body radiation, and I can always substitute this mu by c by lambda, or implies that lambda is c by mu, and I can get in terms of mu. So let's solve in terms of lambda, then I will, okay, when you will substitute it, let's just substitute it lambda by c by mu. So in terms of mu, it will be 8 pi h mu power 5 divided by c power 4, 1 by e raised to power h nu by kt minus 1. So this will be the expression. This is in terms of lambda. This is in terms of mu. You will get this conversion factor here. Okay. Now if you do 2 mu by u key power mu, this constant factor will go away. So we just have to find the proportionality. So okay. So this is 2 mu key power 5 divided by mu key power 5, and this is 1 by e raised to power 2 h nu by kt minus 1, and nu here will be e raised to power h nu by kt minus 1. Okay, so this expression you can write it as e raised to power h nu by kt plus 1 and e raised to power h nu by kt minus 1, a square minus b square. So this is simply this term square minus this term square, this is equal to this. So from here this and this will cancel. So this is proportional to e raised to power h nu by kt plus 1 ki power minus 1. So this was the simple question that was all again asked in a jam exam. So this is u 2 mu by u nu, so this will vary as this factor. So this was a question from black body radiation. This is also a very important topic, especially not for this energy density, but for his wind displacements law and all that. So you should remember, if I increase the maximum, if I decrease the temperature, then the maximum wavelength will decrease or increase. So this is lambda maximum into T. This value is constant. The spectral energy density, this is proportional to temperature ki power 4 with a constant. Okay, this is spectral density, so don't write it as E, just write it as I total, that is a total intensity. This is I. Total intensity is proportional to T raised to power 4 for a 3D system. Okay, like in this year, a CSIR net question has asked this I total give me in 2D. So right now I don't know. I'm sure that you will not be able to solve this in 2D, but the answer is t ki power 3 I total in 1D. The answer is t square. Okay, so for 3D it is t ki power 4, 2D is t3, 1D is 2. Okay, so the another important topic was this black body radiation. So make sure these three are very important topics. Like these are topics from not purely quantum mechanics, from classic, from modern physics. Black body radiation, this Compton effect, this photoelectric effect. So they generally ask the question either in NAT section or in the first single correct option system. So these are the important questions. You can study them rigorously, and if you know all these topics, then it is fine, and I am sure that you will be able to solve the question from these topics. Okay, so these were the three important topics. Start of three questions and three important topics from for for from quantum mechanics. In the next video, we will continue with this quantum mechanics, and we will study some further topics and questions. Okay, thank you. And one more thing, like if you have not shared this channel, share to need ones so that they can all have a benefit for these important topics and all that. So do share with your friends. Thank you.